Hello, welcome to Implementing Micro Focus Service Virtualization at a global pharmacy retail chain. Today's SIG webinar is sponsored by Vivit's Performance Engineering Special Interest Group. Vicky Giavelli is Director of Product Management Performance Engineering for Micro Focus. The portfolio includes Load Runner, Performance Center, Storm Runner Load, Network Virtualization, and Silk Performer. Vicky is responsible for driving and executing the future strategy, roadmap, and promoting optimal solution usage and best practices for Micro Focus load performance engineering products. Paul Shovelin, that's me, Director of Client Management, Checkpoint Technologies. I've been in software testing for over 20 years, and I currently lead a performance test team at the Department of Veterans Affairs. Pitar Piskarich, Associate VP Performance Engineer, Bank of America. Pitar has a deep technical competence across a wide range of technologies, and as many of you know, his MacGyver-esque problem-solving abilities are legendary. And as I mentioned, I'm your host today. Today's speaker is Amit Patel, Principal Consultant, Performance Engineering and Service Virtualization Practice, Patson, USA. We're going to learn a lot more about Amit, but let's first address some housekeeping items. Today's live session is intended for all Vivit members. The on-demand recording, slide deck, and questions and answers will be posted on the Vivit website, visible for all members. We will send you a link via email once they are posted to the Vivit website. If you have any questions as we go along, please type and send them in using the questions pane in the webinar control panel, which we're going to show you here. It usually appears in the upper right-hand corner of your screen. To submit a question, make sure the questions pane is expanded, type in your question, and then click send. Feel free to ask questions about Micro Focus products, as we also have Jacob Vondrak from Micro Focus R&D on the webinar. Thank you for joining us today, Jacob. So let's get started. I'll go ahead and pass it over to Amit. Amit, the floor is yours.
Thank you, Paul. Hello, everyone. This is Amit Patel. First of all, I would like to thank you for your time and attention in attending this webinar. These are two very important things one could give to someone, so that is appreciated. I hope I'll do justice to that in this session. Here's the agenda for today. I'll do a quick introduction of myself and of Patson USA, the company that I work for. We will watch a video. It's a short one of about 3 minutes. And I have been informed that not everybody on this call may be familiar with the service virtualization concept. So I included some slides to fill in this gap. That is what we are going to see in the next section, which is what is service virtualization and software lifecycle virtualization? What is the business case, the need and benefits? We'll then move on to how we went about the tool selection process for our customer and what were the steps followed for the extensive proof of concept that we did. Then we will move on to the post-tool selection steps and the governance model that we have put in for our customer. We will then talk about various different technical capabilities that we have implemented. This is the section where we'll be showing you some animations. It's going to be pretty interesting. Then we'll talk about how we defined our software SV lifecycle, the engagement model that we created, and some examples of return on investment that we have brought for our client. Then we'll talk about what's beyond a service virtualization tool in the next section, because service virtualization is not just about a particular tool or implementing a tool. It's much more than that. We'll talk about that. Then we will talk about how we went with a adoption and sustenance plan for our customer, which has a huge IT organization spanning multiple continents. And then we'll talk about where are we headed next in terms of technology and as a company. And then the last but not the least would be various different challenges that we faced in implementing this platform, the lessons that we learned, and some aha moments. So I hope you'll stick around until the last section. It's going to be really interesting. So this is me. I work as a principal consultant at Patson USA. I'm primarily responsible for the performance testing / engineering and the service virtualization practice of a company. By the way, the QR code is displayed on the right-hand side. So if anybody wants to scan and just have this information stored on your phones, feel free to scan that QR code. I have about 15 years of industry experience in IT, doing performance testing, and I've worked on many different architectural concepts of SOA, microservices, SAP-based architectures, some client-server architectures. In my old days, I used to be a J2E developer and a web developer. I've consulted for about 12 plus companies, and I'm considered as a subject matter expert on SV, application performance monitoring, performance testing, doing evaluating and recommending QA practices, and setting up of COEs at our customer site. I've been extensively trained by Indian Army Special Forces and was awarded something called as a best cadet among 700 cadets by the President of India. So a little bit about our company, Patson USA. We have been a partner of HPE since 2011, and after Micro Focus was launched on the US side, the spin merger that happened, we have been a partner of Micro Focus since 2017. We are their design partner, we are their software resellers, and their implementation partner. We have done the biggest implementation of service virtualization in the world. We have submitted well over 25 enhancement requests for different products of Micro Focus. We are also a QA staffing and advisory and services-based organization. We have been involved in more than 200 projects at our customer sites, testing more than 3,000 applications of various different kinds. From a SV perspective, our mission is to help our clients' IT to significantly scale up their capacity and deliver more projects by boosting productivity and by removing any wait times for any dependent services. Our SLV practice, that's where I'm involved in, is focused on virtualizing applications in lower environments, so that is pre-production environments, enabling IT teams to conduct componentized development integration testing and performance testing, and in some cases, system integration testing by emulating any internal and external endpoints. So we are going to quickly watch a video of a Hollywood star that was filmed about a year and a half ago, talking about service virtualization implementation.
Patson USA was requested by one of the major pharmacy retail companies in the United States to provide service virtualization services for them. Our initial challenges were in identifying what are the use cases where service virtualization could really help and which of those use cases could bring the maximum value. And we identified about 500 different use cases where service virtualization would be used. We invited all of the 4 major suppliers of service virtualization platforms along with some open source tools as well. Instead of having the pre-sales solution architects do this POC, we did a hands-on by ourselves so that we could evaluate the user friendliness of these platforms. So finally, after evaluating all of these criteria, Micro Focus Service Virtualization Platform was chosen as the winner. As of today, we have more than 400 plus virtual services that we have implemented for this client. We have hammered the standalone servers up to 3,000 transactions per second with about 150 services running at any given time. So the performance of the tool is really great. I would look at the performance from 2 different angles. One is performance of the standalone server, which is the runtime environment. That's where we have these 400 plus virtual services running. And the other is the performance of the designer itself, which is the IDE integrated development environment that we developers use. We have noticed that our applications are much more stable in production by using service virtualization. Our performance testers have been able to test the applications with virtualized endpoints that would simulate timeouts, that would simulate slowness and whatnot. So using virtual services instead of the real ones really helps. Our partnership with Micro Focus R&D team has been excellent. This team is very willing to take on additional enhancement requests. We work with them on a weekly basis. We have also a design partnership and we can influence the roadmap of the tool. And so this kind of partnership has been really mind-blowing. The return on investment on service virtualization has been the talk of town at this client. Our leadership loves the investment that they did and the returns that we have brought. So in the past 3.5 years of our implementation of SV, we have upwards of $16 million of confirmed savings in terms of infrastructure avoidance, speed to market, improved productivity, and early detection of integration defects. We are happy to see the customers happy. We have solved a lot of their problems and we would love to do more.
Okay. In case if you'd like to show this video to your colleagues or to your leadership, it can be found on YouTube. Just type service virtualization and scroll down to the good-looking guy, and you'll have the video. So let's jump into what SV and SLV is. SLV stands for Software Lifecycle Virtualization. It is just an evolution of service virtualization. It is the use of virtualization in the pre-production portion of a software lifecycle, and it is the ability to capture and simulate the behavior and data and performance characteristics of dependent systems that are either currently unavailable or are in an unusable state. Let's take a look of what's underneath the hood of service virtualization. So all of the service virtualization tools that are out there, be them commercial tools or open source tools, they work around a concept called listeners. There are inbuilt listeners for transport protocols. So for example, here on the screen, you see there are 3 years. So these are like 3 inbuilt listeners that are listening to HTTP-based traffic, some JMS-based traffic. You can see TIBCO EMS, IBM MQ, SAG Web Methods, generic JMS. They pretty much mean the same thing. You know, they are all working on JMS. I've shown an example of file system listeners. So there are many such transport protocols, and there are multiple listeners built into these service virtualization tools. So they listen to this traffic, and then they provide wizards to add any business logic. So that means you add more intelligence to the traffic that you are listening to. You can also add some performance characteristics to the captured traffic, and that's how you create a virtual service. This is the underlying principle for all service virtualization tools. So let's take a look at how do you make a business case? What's the need for software lifecycle virtualization? On the left-hand side of the screen, you're seeing a traditional pre-prod environment that is not using any service virtualization. You see that the application under test is shown as in the orange color. So that's a system under test, and it's connected to third-party applications. It has its mobile app, it has its own backend system, and it's connected to some legacy systems. Now, without service virtualization, there may be challenges in testing your application. So for example, there might be some access fees that you have to pay when you are accessing a third-party API, or let's say the mobile application is under development, or your backend system, there isn't enough suitable test data, or maybe the test data sanity isn't always maintained. In the legacy system, maybe it has limited access. There might be only a handful of environments that are not connected to your system under test. Now, service virtualization would solve all of these problems that we have stated in this example. So we take out the dependencies and we mock them and create virtual services, and hence we eliminate those. What does it result in? It results in testing of your application earlier. That means you could get your releases out to production faster. You improve the product quality. You lower the infrastructure costs, and you take out the dependency on any constrained systems. So just to recapture all of the benefits that I just talked about, we categorize those benefits into 3 different categories. There's quality. You have much more stable test environments. You have testing, integration testing that could be done earlier in your development cycle. You have increased test coverage. You are shifting your testing left. There are benefits from a cost perspective. You're decreasing third-party access expense, reducing budgets for provisioning and managing testing environments, and you're sharing the virtualized assets. You're reducing your overall cost that you may incur due to late project deliverables, and you're improving the speed of your product. Now, we'll talk about how we went with the tool selection process for our customer and the proof of concept that we did. So here are some of the steps that we followed before purchasing the tool. So we were already handling the performance engineering practice of our customer, and we were using some traditional methods to create mocks using application development tools, IDE, like Rational Application Developer. We were standing up mocks by ourselves, and that was very painstaking because even to stand up a simple SOAP service, we had to put in the skeleton around it and make sure that it is hosted on a powerful enough environment that would be able to handle all of the load that we were pushing through our performance testing. So we were spending a lot of time on that. We made a business case to our leadership that if we were to have a service virtualization platform, we would be doing performance testing much more quicker, and also we would not have to wait or rely on the integration points that were connected to our application under test, mainly because those integration points, those backend systems, were out of our control. We did not have any control on its performance, neither did we have any insight into the performance metrics of those backend applications. So we made that business case. Then we were tasked with, okay, go ahead and conduct a thorough investigation of what are the use cases that the company is going to need. Now, this is where it got interesting, because now we were not just one of the performance testing team was not just one of the end users that was going to be using service virtualization. There were many different lines of businesses within a huge IT organization, like I said earlier, spanning multiple continents. So what we did is we went around, we contacted all of the departments, we started collecting their use cases where service virtualization could help. And when we did this, we had to explain to everyone what the service virtualization concept is. And then we collected all of these requirements from developers, from functional QA teams, from performance team, and actually in some cases from the business analyst team as well. So after collecting all of these inputs from various different domains, we then worked with the integration architecture team, and we collected their requirements as well. The integration architecture team at this particular customer wasn't falling in any of the business domains, and they gave us an additional list of use cases. So when we combined all of these use cases, that turned out to be more than 500 or so. And then what we did is we did a business value assessment for all of those use cases to see where the maximum value could be brought in by using service virtualization. Now, we couldn't do all of these 500 use cases during the proof of concept, right? So what we did is we used a common denominator in the form of a transport protocol. So we divided all of these 500 use cases into transport protocols. So for example, how many of these use cases fall under HTTP criteria? How many of them fall under some other transport protocol? Then we were actually in parallel rallying for funding across divisions since SV concept was new to our customer. We then, once we locked down the scope of the proof of concept, we invited 4 of the major suppliers of service virtualization platforms, the commercial service virtualization platforms. Our team luckily was already aware of some of these tools because we had implemented one of the competitor products at another customer here in Chicago. So what we did is we invited these SV vendors, we did hands-on proof of concept by ourselves. We didn't let the solution architects show us what their tools were capable of. We wanted to feel each of these tools, and we wanted to do this hands-on by ourselves. That was very critical. We then we also evaluated some open source platforms because we were asked to see if there is any need to even purchase anything. So we evaluated about 6 different open source platforms for service virtualization. we did a performance benchmarking at our site, at our own customer site, and we also requested for performance benchmarking numbers from the vendors. And we really dissected these performance benchmarking numbers that the vendors had provided. So we were very careful. We had about a 25-point questionnaire that we asked to these vendors of how they conducted this performance testing. And once we were convinced of, okay, these numbers that they're providing us really mean so and so based on the questionnaire, we were then comfortable with those performance numbers. We also looked at many different functionalities, not just very straightforward, but even functionalities where exceptions, timeouts, if these tools are capable of handling those, if they have the ability to put any security controls for virtual services, whether or not they are capable of any doing attachments for like MTOM attachments, are they able to simulate long-running processes or asynchronous processes? Are they capable of doing any B2B like EDI transactions? We checked whether they can do this. They conform to various web service specifications like WS security, WS policy, WS RM, and WS addressing, so on and so forth. And also whether they are capable of handling binary messages, any fixed length protocol related messages, so on and so forth. So it was a very extensive list of business criteria that we had collected for this tool for the proof of concept. And then what we did is, after we did a hands-on POC of all the tools, we did a weight point average type of scoring system. And then we divided that into 5 different categories. So how was the pricing, capabilities, configuration, flexibility, and resources? So I'm just going to show you an example of 2 of the top contenders that we had shortlisted to purchase. So you can see that we, for each of those points that I mentioned, we had further categories. So for capabilities, we had features, we had various different purposes. As you can read that, this will be available after the webinar as well in the slide deck. I'm not going to go through all of them. So we did a scoring system based on the weightage that I talked about earlier, for capabilities, for configuration, for flexibility, for resources, and for pricing, obviously. So once we selected a tool, let's talk about what did we go through as a post-tool selection process, and what was the governance model that we had to put up. So we had to work on the hardware sizing requirement because this tool was going to be used throughout the enterprise. So we had to make sure that the hardware was going to be sufficient to handle the workload across all lines of businesses within the organization. So we came up with the final TPS numbers that we came up with was about 3,000 transactions per second is what we needed to size this environment to, because this was going to be heavily used for performance testing throughout the organization. Then we worked with the selected vendor. So in this case, it was Micro Focus. And I was very pleasantly surprised that they had done a very good analysis. They had even given us the CPU specifications that would be needed to achieve the 3,000 transactions per second. So that made our life a whole lot easier. We then went through the procurement process of the hardware. At our customer site, we had to face the usual dilemma of whether we should go with a virtualized hardware or a standalone hardware. Then we went through some validations with our security teams at the customer site. They wanted to make sure that the tool stores the data appropriately, that there are enough controls around it, that nobody unauthorized can get to the data that we were capturing. Because let me remind you that these tools can sniff data from any environment that you connect them to. So in some cases, if we were going to connect it to production to just sniff out some request response pairs, there was a good possibility that the data that we collected would have our customers' data. So we had to go through an extensive tool validation process with the security teams. Then we did a software installation, and Micro Focus HP at that time helped us in doing the installations. It's very straightforward. There wasn't anything much complicated in the software installation. We just had to make some decisions of whether or not to use a SQL Server Express edition or an enterprise edition, and so on and so forth. Then we conducted training sessions formally. These were done for our team members and some other team members that were going to use the service virtualization platform. Then we set up the governance model. Because we already had experience implementing service virtualization using another tool at a different customer, this was a little bit easier for us. I mean, we had some data to rely on. So we created a governance model. Just to name a few things underneath it, we did a decent estimation model of how to estimate when a requirement comes in for service virtualization. We did a service virtualization SDLC process that I'm going to talk about in the later slides. Then we developed a communication strategy and things like that that are typically needed for governance. At this organization, since everybody was new to the service virtualization concept, none of the project management teams or the program management teams had any tasks for service virtualization in their templates. So we had to work with all the project managers and program management groups throughout the organization to ensure that they indeed put a task for service virtualization, or at least check with the service virtualization team if this would be needed much ahead of time. That is the process that we did. That means it was a SV injection into the any program's SDLC at the customer side. We created a work intake process, basically a ticketing mechanism using Jira, and asking the right set of questions to our customers who needed service virtualization. We developed a communication strategy. We would conduct roundtable sessions. We would have monthly bulletins going out of what service virtualization was doing. We would try to focus on the ROIs and get more and more teams involved with us and get more virtualized services created for their own benefits. We developed a very extensive hardware and software maintenance process. At this customer side, our team maintains both of these things. We had to create a couple of inventories as we realized that there was a lot of demand coming in for service virtualization. We had to have separate inventories for the virtualized services that we were creating. And these inventories are very extensive in the number of fields that they contain. We also created inventories for managing the MQs that we were having created for our service virtualization purposes. We maintain a firewall inventory because at our customer, none of the two machines can talk to each other directly. There has to be a firewall that has to be open between any two systems. So we were maintaining that kind of firewall inventory. We did a quick FAQs for troubleshooting for our internal team members. If something was broken, what are the steps they need to follow to quickly get it up to speed again. We also did software installations across the infrastructure. This is not just a regular HPSV installation, but the other softwares that are needed to go along with it. So for example, you need an MQ Explorer to drop messages for testing purposes, so on and so forth. We did an inventory to to track the various different access levels that team members had. Because as our team grew, eventually at one point we had 17 members in the service virtualization team alone, and we had to track what each person had access to. We have a wiki site that we have developed for our end users that displays the various different capabilities. Then we developed a SV operational model, and I'm going to quickly talk about what was involved in it. I'm just showing here the RACI portion of the SV operational model. So we had SV organization charts, SV team roles and responsibilities, and what are the roles and responsibilities that are needed from our client teams. That means from our requesters like business team, development team, QA teams, pre-prod run teams, that means environment teams, and some enterprise shared services teams. Here is the process flow that we had developed for the operational model. So as you can see, if somebody submits a SV request, we review that request and we make a decision whether or not a virtual service would really help in this case. So if the decision is yes, then we move to the estimation phase and request for funding for that virtualized service. We then provide a high-level SV scope and approve funding for resources, and then it gets assigned to the SV developer who then works through the next steps, which is reading through the high-level design, solution architecture documents, working with the requesters, so on and so forth. Let's take a look at various different capabilities that we have implemented. This is where we get into the more technical stuff. So in the video that you saw, that was actually shot a year and a half ago, in which I stated we had 400 services by then, but now we have upwards of 520 virtual services that we have implemented. We have done many SOAP and RESTful services for HTTP as well as HTTPS. That's a secured version of HTTP. And this tool is capable of doing both one-way as well as two-way SSL communication. We have done some fixed length protocol virtualized services. We have done some virtual services that use the binary message formats on various different JMS platforms. So at our client, we have IBM MQ, Data Power, we have Software AGs, Universal Messaging Platform, and we developed some services on the file system protocol and also using FTP and SFTP. We have some limited services that use TCP-based virtual services. Then we did SAP virtualization. Now, let me just quickly tell you what SAP virtualization is. So basically, SAP components talk to each other using IDOC messages. So if one of the SAP components is not available, this is where you could use service virtualization, and the SV would start acting as if it is a SAP component, and it has the ability to communicate using IDOC. So we did that. We did something called as Java virtualization. So what Java virtualization is it's the ability to modify the behavior of any particular method within your Java code. So let me give you an example. We were asked to do performance testing. I mean, one of the performance testing teams came to us to solve this problem. So there was this authentication mechanism, and there was this particular method that was asking, is the authentication okay? That means, has the user come in through the right channels? If it is yes, then it would allow the application, the end user to go into the application. And if it is no, then he would be denied the access. So we had to overcome this because it was just practically impossible to create 8,000 different user IDs for them. So what we did is we used this Java virtualization, and the tool allows you to do that. And we just looked for that particular method, and any calls coming to that method, we would just redirect them to virtual services, and the virtual service would say, yeah, authentication is okay, and we would let that person in. So this is how we did Java virtualization. The next is database virtualization. Actually, I should have named it JDBC virtualization. So this is the ability where we could replay the SQLs, or actually the SQL results. So let's say if you have a Java application connecting to a database, but that database is not available for some reason, or let's say different developers in a team need access to different schemas of database at the same time. Now, to stand up such things is kind of time consuming depending on which organization you're working in. So we have this database virtualization implemented. So our tool, the SV tool, acts as if it is the database, and it looks for those SQL communications, and it responds back with a result set. So the application under test will never know that it's actually connecting to a virtualized database. And I have a picture to show about that. Then we did something called as device virtualization. So this was done outside of the SV tool. We were asked by one of the automation teams to solve a problem. So at our customer site, every business flow begins with a prescription. So somebody brings in the prescription, the technician working at our stores, at our customer stores, they scan the prescription through a physical hardware. Now, somebody had, before we came into this customer, somebody had downloaded some DLL from the internet that was not supported. That would act as if it is a physical scanner. Now, after they migrated from Windows XP to the next version, I believe to the Windows 7 version, that DLL broke and there was no support for it. So that resulted in about 350 automation test cases not being able to execute. And we were asked to solve that problem. So then we looked at it and we figured out the underlying mechanism of which service calls are made after somebody scans through the physical hardware. And we basically created the same mechanism to call those underlying services, and that's how we overcame that challenge, and that's what we call as device virtualization. In addition to that, we were always asked to see our customers don't really understand the difference between what is capable, what is possible through a service virtualization tool versus not. So sometimes they would ask us, can you do virtualized data creation? So instead of just flatly saying no, what we did is we went on this path of creating web applications for data creation. So as of now, we have about 19 different web applications created for this particular client just for data creation. And then we have our own health check mechanisms that we have created to proactively monitor our virtualized services. Now, let me just quickly show you one of the examples of service virtualization. This is at one of our customers' site where the very last call to a integration point was taking a couple of days because it was a manual process. Somebody would be notified that there is an incoming request for them, and then that person would pick up that request, go to the storage center, and then manually check whether or not that thing is available there, and then respond back. So that turnaround was 4 to 5 days because this was done internationally, and this typically halted the testing for that much amount of time. So this is how it worked without service virtualization. I'm just showing this to show you how virtualization could be done for a file system based communication. So on the left hand side, you see a user who is using a SAP GUI, and he does something called as a delivery, and obviously that SAP GUI is connected to the SAP server, and that delivery is then converted to a IDOC message, and that IDOC message is dropped onto some queues, and TIBCO then picks it up. That was the middleware they were using. Once TIBCO picks it up, it puts it on a particular folder in a file system, and then the third party in another country would pick up that message shown here in number 5 in the sequence, and then process that message after a couple of days and drop it again on the folder 4 that can be seen here. TIBCO then would pick up that message and send a PGI, which is, I forgot the full form for it, but it's a SAP terminology. And then SAP would mark as delivery completed. This is the process that was there without service virtualization. Now, what happens when that connection breaks, or if there are too many delays from the third-party side? Basically, the end user is stuck at that point. So this is how we recorded the traffic using Micro Focus Service Virtualization tool. You can see that we reconfigured the file system. We just created two additional folders and had TIBCO drop off these messages at those folders, as you can see here. So basically, instead of the third party picking up those messages, we had Micro Focus SV tool pick up the messages as is indicated here in sequence number 5. Then it would send that message to the real system indicated in sequence number 6 and 7. The real system would then pick up that message, send it back using sequence numbers 8 and 9 shown here, and then it would process back to the end user. This is what we use to learn the traffic. So when I say learn, these tools all have a sniffing ability. That means a proxy ability. You could run any traffic through them, and it will capture the request and response pairs for that communication. Now we broke the connections from Micro Focus SV to the third party, because now there is no need to send that communication to the third party, right? Because we were trying to get rid of it just to make it run quicker. And once we cut that connection, we put the virtual service in something called as a simulate mode. That means it's running on its own. So this is how the topology looked. So the Micro Focus SV tool is now responding back with a message, as you can see here. Now let's take a look at another example. So at our customer site, they have upwards of 10,000 of stores throughout America, and they have these workstations that are connected to their local application called CPD, Central Prescription Delivery, which is then connected to a central prescription app that's sitting in the data center. It has its own database, and any calls coming for any get customer calls or get detail calls go through a channel to a centralized omni-channel application. That is what I'm trying to show you here. It's just the intermediary architecture that it follows. So a message is dropped to a first set of MQ, then is dropped to another set of MQs, and then the omnichannel backend picks it up and then responds back with a message back to the workstation. And this is done for all get calls. For all update calls, our customer uses a tool called, it's an Oracle-based software called Golden Gate, which basically looks for any commits to the database, and then it transports those calls to the omnichannel. This way, everything is synchronized. So as you can see here, at the top portion, that's the mechanism followed for get calls. The bottom portion is for update calls. Now, we were tasked with this challenge of creating a system like omnichannel, and this was a really huge task because we had to now think about synchronization of data for not just for get calls. We couldn't just do static responses in this case. We had to be very dynamic. The data had to be consistent across multiple databases, and putting another instance of Golden Gate was super expensive. So this is what we came up with. So this is the local application connected to central application. No changes so far. Then it drops the message to an adapter server and then to a MQ. From here, we pick it up. That means the SV tool picks it up, and then this SV tool is now acting like the virtualized omnichannel. Now we redirect a call to a SOAP service that we built using Java. This SOAP service would go and read from the database. So now the SOAP service is acting as if it is a Golden Gate. We evaluated different architectural concepts around this, and this was one of the straightforward ways to do it. So now we are responding back to the workstation. So in this case, we overcame this challenge of synchronizing the data, right? We are not just responding with static messages, but indeed this data is synced across all the databases in the system. And we had to write some heavy business logic in that SOAP service. That's why we just spin it off as a different application. Earlier, I was talking about this database virtualization concept, and here you can see how it's done. So basically, you make your application under test. You give it a different JDBC connection string, and that's using that connection string, the SV server picks up any messages going to the real database. So that means the SQLs will now flow through this SV server. And if needed, they can be redirected to the real database, or they can be just responded directly from the SV server back to the end user. This is the high-level topology that we implemented for this customer. So there is the designer that's sitting on our laptops, and then there is the runtime environment. This is where the Micro Focus SV server portion is sitting. All of the services that we created are deployed on this particular server, and this tool needs a database for itself. That's why we have created a separate licensed SQL Server Enterprise version of it. Now let's take a look at what is the SV lifecycle that we followed. So as in any software SDLC, we follow typical steps. So for requirements gathering, we have the SV requesters fill out requests using our Jira. We then gather and understand any solution architecture, high-level designs, low-level designs. We look at the physical and logical topologies and that kind of thing. We try to collect at least 2 sets of request and response pairs from the real service developers if they are available. And if the real service is functionally tested, we gather the SOAP UI project if there is one. We have extensive working sessions with the requester team to better understand the requirement. And we then create sequence diagrams. We then open the firewalls. This is what we do in the requirements gathering phase. Then we move on to the analysis. So we identify all virtual services that are needed and see if those are actually needed. Then we make a decision. And then, for example, I'll give one instance where we avoided virtual service creation. We just used some code that would just not make a call to that particular database because that database was just not at all important in the process flow. We then finalize the technology that is used in addition to Micro Focus SV tool. So if there is a need to create any separate Java web services and things like that, or if there is a need to create any web application, And if the service is going to be built, we decide then whether we are going to learn the traffic or are we going to hand build the service. Then we move on to design. As in any software, we create a design document for the virtual service, and then we submit this design into our team's SharePoint site. Then we move on to the implementation. This is where the SV developers will actually build the service, and there are multiple ways to build a service. We are not going to get into details of that, but maybe you can do a demo or something of that sort in the future. And then we do a testing. And in this testing, what we do is we do our own unit testing using SOAP UI or something like Postman and such kinds of tools, or MQ explorers to drop any messages. Then we move on to integration testing with the real application. So this is where we make the real application point to our virtual services instead of the real ones. And that's how we do that. We then just deploy and maintain that service and make any changes that are further necessary for the requester. Since we have been extensively doing performance testing for our client, we have a performance COE as well as a service virtualization COE at our customer site. We created this unique engagement model that is applicable to both waterfall as well as agile methodologies. Without getting into too much detail, I'll just say that the blue portions are applicable for the performance COE and the green ones are for the service virtualization COE. Again, this content will be available for you later. Now let's take a look at an ROI example. Initially, we didn't have a proper mechanism to display what the return on investment is to our customer. So this was from the very first project of service virtualization. That application, I just renamed it to ABC, and we this allowed us to conduct simultaneous testing of 2 different code bases at the same time. It reduced the dependency on availability by 80% and allowed narrowing focus on that application's bottlenecks rather than integration components. So we were not really putting dollar amounts, as you can see in our first ROI. Then in the second project that we did, we started putting dollar amounts. So in this project, we had about 84 integration defects that we caught just by using service virtualization. That would have been impossible to catch without SV. And then we put a dollar amount of $2,000 per defect, and that was our ROI. So it was pretty rudimentary. And then later, as we evolved into more as we evolved as a service virtualization team, as a COE, we then got into more complicated things. And what we did is we divided the 500 or so services that we implemented into 4 different categories. Which of those services helped us avoid environments? Which of those helped us avoid caught the early defects in integration? Which of the services helped us increase the speed to market, and which of the services improved productivity? So if you add all of these together, it comes to about $16 million. This is a 1.5 year old slide. You can see the improved productivity is less, because this is where we got into hot waters with our clients sometimes, because they were not really readily acceptable to the fact that they were not really productive from the get-go. Since we became so successful at this particular client, that invited some spotlight and I would say like a media attention. So if there was something broken in an environment, and if that environment was using virtual services, they would first blame the virtual services team. So what we did is we created proactive health check mechanisms for all of our virtual services. And these health check mechanisms run every 15 minutes. They notify us via email if something is really broken because of us. And it automatically logs tickets to us as well as to any supporting environment teams. And we display the appropriate on or off flags on the developers' websites. We monitor the usage of all the virtual services that we have ever built for them. We have about 19 web utilities, like I mentioned, and we do something called as we hook up every application to this monitoring utility so that we can monitor the usage of it from a functional perspective. We also monitor the performance, and this is inbuilt into this SV tool. We being so successful, we had to make sure that SV continues to be adopted and there was a sustenance plan in place. So this is just an example of the presentation that we did to our customers at the client side. So we told them, if you don't adapt to service virtualization, basically you are going to fail. That's the gist of this particular slide. Now, what were the different tactical techniques that we implemented for fostering adoption and reinforcement of service virtualization? How do we force the developers or the QA team to use service virtualization for the benefit of their project? So we created focus groups, we did many managerial interviews, audit compliance, performance measurement, so on and so forth. So we have a mechanism for that. We gave recommendations to continue to take the training that our SV team provides throughout the organization. Now, let me quickly talk about where are we headed. Now, where are we headed is, in short, we are in the process of building something where we just scan the WSDLs, or we just create a skeleton virtual service that does not have much business logic in it. And we just spin it off, we just deploy it, and let the developers by themselves or the end users by themselves put some business logic on top of it. This is where we are headed. So instead of us, the SV team, creating all the virtual services from A to Z, we are seeking help or allowing the end users to create virtual services by themselves. This is something that is in the works. We are also working on some IoT related virtualization. So unfortunately, due to confidentiality reasons, I cannot really share about that IoT technology that we are implementing, but just be reminded that the SV platforms already has a support for IoT. Now, to the last section, what were the challenges and some good and bad moments? So expectations, defining the line between service virtualization, data creation, hardware virtualization, database virtualization was very critical for us, because like I said earlier, not all of our end users were aware of where to draw that line. What is possible using service virtualization versus not. So we are typically looked upon as a team that is an innovation team, that if given a problem, we are able to innovate. That is what we ended up doing. We had many debates on whether or not service virtualization is a specialized skill or is it a commodity skill. So I don't want to get into a debate about that, but that is up to everybody's own imagination. Whether or not SV is fit for microservices. There were surprisingly some calls made by some statements made within the organization that for microservices you can't really use SV, but that's actually not true. There were some tool ownership decisions. Who should be owning the tool? Should it be given to the developers to use by themselves, or should there be a centralized team who is already aware of all the functionalities of such a tool? Those were some of the challenging discussions. And then on the technical side, dealing with asynchronous services, any stateful services, and persistent services that store data into databases. So we had some challenges in working on such virtualized services. Then if we were to learn any traffic in a lower environment that was broken or did not have the right endpoints, how do you sniff out any traffic? So basically then we had to rely on reverse engineering. Based on the design documents, we would think, oh, maybe this is how it responds. And it was through trial and error mechanism that we created such virtual services. And creating our own patches using Visual Studio. Yakub, who is on the call, helped us create our own patches for the service virtualization tool, something uniquely that our customer was doing that is probably not done at any of the other customers. So we had to create our own patches, and that's possible using this tool. Doing the ROI calculations, there is no fundamental formula for this, although we have very complicated sheets to calculate the ROI. But those were some of the challenges. If we were asked at point blank, hey, how much dollars did you save on this project? And we wouldn't really have an answer for that. Any integration defects, like I mentioned, blame SV first, because that environment was connected to service virtualization, but we overcame those challenges by having a proactive mechanism and having some data even before somebody would blame us. And the very last thing, this is one of the aha moments. So all the leaders that owned us at this customer team got promoted. So this is something as a key takeaway if you're looking to run this SV concept through your leadership, I would keep that particular point in mind. If you have any questions, feel free to email it to me. My information is displayed on the screen. So is my phone number. You can scan that YouTube video that you saw, or you can scan this QR code. And if you like what you see or what you heard today, feel free to engage us, Patson USA, for any service virtualization needs that you may have at your site. I would like to pass this to Paul now, who would be talking through the next 2 or 3 slides. Paul, it's up to you.
Thank you, Amit. Wow, that was great. Very interesting. A lot of great information there. So the questions will be answered offline and included with the slides and recording. Everyone will get a notification when they're available. The ITEM Summit, join Vivit at the ITEM Summit to learn how to use hybrid IT as a competitive advantage through lessons from customers, partners, and Micro Focus's own internal experience, February 5th to the 7th in Phoenix. Register today at the link shown on the slide. And we have some other upcoming Vivit events that we're very excited about. Please be sure to register. Let your colleagues and customers know as well. These are also available on the Vivit calendar. We hope you can join us. And if you want to say thank you, when this session ends, there will be a survey available to you. Please fill out the survey. It's very short, and it really helps us bring you the content that's relative to you and meet your needs. So we appreciate your attendance, and we appreciate your time, and thank you, everybody. Have a great afternoon.
Thank you.